Have you ever tried to build something really complex? Like putting together furniture from a kit, or maybe even trying to carve a sculpture out of a solid block of wood. For years, building powerful AI was a lot like that sculpture. It was slow, it was incredibly expensive, and it was really only for a handful of people with super specialized tools. But what if all of that just changed?
What if, instead of starting with that raw block of wood, you were handed a sculpture that was already, say, 99% finished? All you had to do was add those final, creative touches to make it yours. Well, this isn't some hypothetical. This is exactly what's happening in the world of AI right now, all thanks to a game-changing technology called foundation models. We're talking about a shift that's turning what used to take half a year and millions of dollars into something you could literally prototype in a single weekend. So how on earth did we get here? Let's dive into the secret sauce.
Okay, to really get why this leap is so massive, we have to look back at how we used to teach AI. For the longest time, the main method was something called supervised learning. It was powerful, for sure, but it had one major, and I mean major, bottleneck.
Just look at the difference here. With the old way, supervision, you needed actual people to label every single piece of data. Imagine you're training an AI to spot credit card fraud. You'd have to pay people to sift through millions of transactions and label each one fraud, not fraud. It is painfully slow and unbelievably expensive. That labeling cost was like a giant wall, stopping AI models from getting any bigger. But then came the breakthrough, self-supervision.
With self-supervision, the model, it basically teaches itself. Instead of waiting around for humans to label data, the model figures out how to create its own labels just from the raw data itself. And think about what that unlocks. The AI can now tap into the biggest library ever created, the entire public internet, and learn from it, without a single human having to tag anything first. It's a total game changer.
So how does this self-teaching thing actually work in practice? Okay, let's look at a really simple example. The model takes a sentence, right? Like, I love street food, and it turns it into its own little pop quiz. First, it looks at the word I, and its job is to predict the next word, love. Okay, cool. Then it takes I love and tries to predict street. It just keeps doing this over and over, turning a single sentence into a whole bunch of tiny training lessons. Now imagine it doing this billions of times with pretty much all the text on the internet. That's how it builds this incredibly deep statistical understanding of language.
So this amazing ability to learn from mountains of text gave us what we call large language models, or LLMs. But the revolution didn't stop with just language. Researchers pretty quickly realized this powerful self-teaching trick could be used for a whole lot more than just words.
And this right here, this is the crucial leap. Once they cracked self-supervision for text, they thought, hey, wait a minute, can we do this for images, for audio, for computer code? And the answer was yes. The result was a whole new class of models that could process and connect information across all these different formats. They weren't just large language models anymore, they evolved into foundation models.
So what exactly is a foundation model? Probably the best way to think about it is like a master chef's universal starter sauce. This sauce has been simmering for ages, developing this incredibly deep, complex flavor. Now, instead of making a new sauce from scratch for every single dish, other chefs can just take a scoop of this starter, add their own ingredients, a little spice here, an herb there, and create a totally unique gourmet meal in a fraction of the time. That's the huge shift. We're not training one model for one task anymore. We're using one massive foundational model for many different tasks.
Okay, we get that they're powerful and super versatile, but what's actually going on under the hood? How do these things think? Well, beneath all that complexity, the core idea is surprisingly simple. At their heart, they are just incredibly sophisticated completion machines.
This quote from AI expert Chip Huon just nails it. When you give a model a prompt, it isn't thinking about your question like a human does. It's making a highly educated, statistical guess about what should come next, based on all the patterns it learned during training. And it does this by predicting one little piece at a time, something called a token.
Let's break this down. A token is the basic unit the model works with. It might be a whole word, like can, or just a part of a word, like the ent in can't. The model's entire job, its only job, is to predict the most likely next token, add it to the sentence, and then do that whole process again and again and again until the thought is complete.
And this is where the real magic happens. This super simple act of just predicting what comes next can be used to solve incredibly complex problems. You give it a long article and just add TLDR at the end, and poof, it gives you a summary. What's absolutely wild is that at this huge scale, the models start to develop what are called emergent properties, skills they were never even trained to do, like reasoning or basic math. They just appear. And it's all just from being a really, really good completion machine.
This whole shift has created a brand new discipline called AI engineering. It's less about building models from scratch and more about being a creative problem solver, an artist who finds clever ways to use these incredible foundation models. And you can start thinking like one right now. Let's try a quick 1-minute challenge.
Okay, your turn. First step, identify a repetitive task you do all the time. Maybe it's summarizing meeting notes or writing basically the same email over and over. Second step, frame that task as a prompt, like you're asking it to complete a thought. For the email, it could be something like, write a polite follow-up email to a client about their project status. And third, this is the pro move, add context. Paste in the previous email thread or just a few bullet points about the project update. That extra knowledge is the secret sauce that helps the model give you something truly useful.
If you just did that seriously, congratulations. That thought process, spotting a problem, framing it as a completion task, and then giving it context, that is the absolute core of what modern AI engineers do every single day. You're not carving the sculpture from a raw block of wood anymore. You're the artist, adding those brilliant final touches to a masterpiece that's just waiting for your vision. The foundation is already built. The tools are in your hands. So the only real question left is, what are you going to create?